We are on lesson one. I have Jack Armstrong from New York. Slide one. Slide one says go to your Finder and find your command prompt. Type in your command prompt, then hit enter on the PC Finder, and this will pop up, which it did for me already. So I've done that already, all of these steps. There's a slideshow, and I changed the color to gray. So it looks more like you can change the color by right-clicking the bar and going to the properties. And then they don't have a lot of good choices, but I like gray today. So for today, it's going to be gray. So let's keep going down the slides. And now this slide tells me if I write, and here's my little star. If I write Python there, I can start an interactive session. Do I really want to do that? Let's go to the next slide and see what's going on in the next slide. Next slide, yes, it looks like we want to do that. So I'm going to type in Python. This is the Python application program. And because I'm not feeding it some file like a file like this, a text file with the name example1 with the extension py, which might contain what? Python code. Since I don't have that, if I hit enter now, Python will just compile it. But if I don't have anything in front of Python and I just hit enter, I start running the interactive session with Python. Now the interesting thing is not all languages have this. So Java does not have an interactive mode, and neither does C or C++. Python has that. And that's why it's very easy to test your code. So you can just write a few lines, test it before you actually put it in a file or something. And here we have this. So I'm looking at my slide and it says type x equals 6. And what's happened is if I hit enter, this statement of Python code will be analyzed, executed, and something will happen. So let's see what happens. Oh, nothing happened, or did something happen? Do you remember anything? What do you think happened here when I hit enter? What kind of things happened?
What, x equals 6?
And I'll add to what you tell me, Jack.
So right now you only have x equals 6.
And I hit enter, and then what happened? What did the compiler do? Python compiler.
It made the reference
very good
equal to the integer that you put.
Very good. Very
and it made the type integer as well.
Yes, very good. And all of this happened at runtime. So let me pull up 1 second. If I can get to my, here we go. I think no, it's this one. I'm getting so good at this. Did you see how I found it?
That was crazy fast.
Thank you. So the problem was it was hiding behind something. So here we go. I am going to write this run time typing. The kind of data type, for instance, 6 is a integer, and in Python we call integers int. 6.5 is a decimal, and we call decimals float because of the floating point. The point moves around in a decimal number. So in Python, integers are called int, decimals are called float, and if somebody says, hey, what is the type? What is the type of 6? You go, it's an int. So 6.5, is it an int or a float? It's the data type we call 6.5 a float. So that's what's going on. So right now, x is, so when you type in x equals 6, what Python does, the Python compiler does is, first thing it does is that it creates an object. Pull up my Blackboard here. So we're trying to interpret what this line does. X equals 6. So first thing that the compiler will do, compiler does the following, and perhaps in this order. First, it creates an object represented by the symbol 6. So it's kind of going from right to left. It does this first before it does the assignment. Before anything, it's going to create the thing on the right-hand side. And so it creates an object represented by the symbol 6. And then what it does is it associates, and then creating an object is like a 3-step process or something like that. So first it creates the symbol 6. It takes 6 as a representation for an object, which turns out to be an int because 6 is an int. So it creates an int object, associates, puts the literal, and all of this will clear as we go, will make more sense as we go on, puts the literal 6 in this object that was just created, and 2, associate all the functions like plus, minus, division that ints, as in integers, can do. So in other words, by just writing 6, all of those things happen. An object was created, and in that object was the data fields or the variables in which 6 was stored, and with that, the functions were there as well. So now 6 is an object that can do things on itself, do things on the data contained in it, which is the literal 6, the integer 6. Once that has happened, once the object on the right-hand side has been created, then the compiler, Python compiler does the assignment. It takes the object and assigns it to X. And so it assigns the object represented by the letter 6 to the reference variable X. And so we're calling X a reference variable, which is currently pointing at an int object. Okay.
Okay.
Okay. So number 3, we're all done. Reference variable X is pointing or referring to an int object, which contains 6, even though it's represented by that letter 6 as well. All right, so there we go. Now let's move on. Don't save. No, I don't want to. I'll just do this. Okay, so that's what's happened here. Now that we have x equals 6, I want to know that the data stored in x, what is the type of that data? Or what kind of reference variable x is. And so it's kind of like the same thing. And we start thinking of x as the same as 6 informally. But in fact, they're different things, right?
Okay.
So a type is a built-in function that tells you the data type of whatever you put in its argument field. So this is parentheses, open and close means this is where you can put the argument. So and it takes one argument. So I put x. When I hit enter, it tells me that x is a reference variable that points to an int object. Okay, or x is a kind of a variable that is currently holding an int object. If I did this and hit enter, assignment has happened. What kind of object is now x pointing to?
A string.
A string. Because if I did this, I get the string back. Actually, yeah, I could do this again. Let me do, when I do that, the string is gone, replaced by 6. And then if I do x, currently x refers to, points to 6. Okay.
Got it.
Now here is our math lesson for today. So what's a dividend? It's the number you put in this little in this little house. Then the divisor comes here outside. Divisor is the number that you divide into 24. And you get the quotient, which is the answer. So when we talk about division, when we talk about dividing, usually what we want is this number here, the quotient. So division is about the quotient. Okay, so that's number one thing to think about. So when we'll be soon looking at division operators in Python, and we'll find out that there is a division operator that actually returns a remainder, which uses a percentage sign. Okay. But the other two, the integer division and the float division, the decimal number division operator, they return the quotients, truncated, rounded up or down, all of that. So let's keep going with our, but we haven't got to the Python yet. We still need to make sure we remember all of this. I always forget because I was pretty sure this was called quotient, but I made sure I checked the internet. Here we have another example. Because this here, we only had the dividend inside, divisor, the number that divides into the dividend. And do you know what happens here? 4 times 6 is it 24? I think it is. Because
because they divide evenly, so they multiply.
They divide evenly, there's no remainder. Okay.
No.
Yep. Now, 2 times 3, it gives us 6. It's not large enough. 2 times 4, we get 8, which is pretty close to 9. So we go with 4. 2 times 4 is 8. And then we subtract. So subtraction happens and 1 is left. And that's the remainder. If you continued with this division and you wanted to make this 4 right now is the answer that we were seeking when we divided 2 into 9. But what if you wanted a decimal number up here? That's when you put a point here, right there. So I'll bring my cursor. You put a point here, and that allows us to put a 0 here. And then we can, so that is a 0. Then we can say, so there's a decimal point here, and then 2 times 5 is 10. And then the decimal quotient answer to dividing 9 by 2 would be 4.5. So what I said just now, let's keep going. So here is another example. You got the remainder here. The reason why I took this picture from the internet is because of the minus sign. You can see that 9 times 8 is 72, and we subtract that from 75. 3 is the remainder. And again, if you want to continue this, where our quotient becomes a decimal number rather than integer, we would have to put a decimal point right where my cursor is. And that would give us a 0 here. And then we can do 9 times 3 is 27. It will go on. Okay, let's keep going here. Here we have the second step done without the decimal point. And then it ends up with, when you see a 0, usually I used to put an X here. I don't know. 0 means there is no remainder, sorry. All right, so this / is called the Python's division. Messed that up. Float division operator. Okay, so / single, just one. If you have 2, then that's Python integer division. Oh, sorry, division operator. Okay, so but in this slide, we're dealing with the float division, which means that this says, please divide 11 by 2 and give me the quotient, the answer, quotient that comes up here. And the answer better be in decimal. So in other words, if I were, let me use this again. In other words, don't stop here, keep going. So if the number is 11, move this a little bit here. Don't stop where you go 2 times 5 is 10, remainder 1. Don't stop there, keep going. Keep going until you have no remainder left and you have a long decimal number here. And that's what's happened here. So if you divide 11 by 2 and do what is called decimal division rather than integer division, you're going to end up with this quotient, which is written here. Okay. Now, does it have to truncate? No. Does it have to round up? No, because this is decimal division.
Yeah.
Right?
When you're using the integer division, it truncates.
Yes, because because we want the answer to be in integer without a decimal point. So it's forced to truncate or round. It rounds when it's a negative number, truncates if the quotient is a positive number.
Okay.
All right. Okay, so let's keep going. Next slide. Oh, in fact, let's do it here. If I type in, so we are now on the Python interactive session. Now I want to do a float division here. I want to divide 11 by 2 and I get 5.5. Now so that is the float division. Here's another example. I'll do it here. 11.6 divided by 2.0, which means this is a decimal number, this is a decimal number, and we got a decimal answer because we were doing float division. We were doing decimal division. In fact, if you look back to what happened here, this number was an integer, not a decimal number, not a float. This was an int, not a float, but because we use the division operator, the answer came back. Answer came back as a decimal number. And here I have the integer division operator, 11. We want to divide 11 by 2 using the integer division operator, which has two, which the symbol for that is 2 /. And here, this is what the compiler does. I mean, at least the way I'm thinking about how it would be going about doing it. 11 goes here, that's the dividend. 2 is the divisor. 2 times 5 is 10. There's a remainder and it stops there. And you get 5. But in fact, it doesn't stop there, right? We discussed that last time. In fact, it goes all the way and does the division. So let me do that. In fact, what it does is, okay, what it does is it goes on to, it puts a decimal point there, which allows, so I'm doing a decimal division. So I put a decimal point here, that gives me a 0. And now I can do 2.5, and that will give me 10. And we are done because the remainder is 0. And now what happens? So in other words, even when you do integer division, the compiler goes on, finds the decimal quotient, and in this case, since it's a positive number, it truncates it. It just drops the decimal point and everything after it. That's what truncation means. So in other words, it does this. It just truncates in your left hand side. Okay, all right. Next slide. We have 11 integer division 2, you get 5. And here we have minus 11, which is a negative number. And it's also an integer divided by another integer 2, and you get minus 6, because in this case, you don't truncate the answer, but you round up. You go to the next. So because the answer would be minus, the answer was this right here.
Okay.
Minus 5.5. If you divide minus 11 by 2, you're going to get minus 5.5, because the compiler always actually does decimal division and then truncates to give back the user the integer he wants, especially when you make integer division. And in this case, there's a minus sign, which means it needs to round up to the next smallest number, which is minus 6. Okay. All right. Let's keep going here. And here we are using integer division, but the number here is a decimal, and here we have a 2. Therefore, the answer will be in decimal.
Okay.
So the only time you get a answer back in integers is if both of these are integer numbers. Okay. All right. Let's move on. And then here is the power operator. 11 raised to power 2 is how we do that. So let me write that here. If you want to, let's raise 3 to, so let's do 3 raised to power 3. That means multiply 3 times. 3 times 3 is 9. 9 times 3 is 27. Let's do 3 raised to power 4. Well, I think we're going to get 81. And there you go. All right. And then here, what's happening? Do you remember this, Jack?
Yes.
So this
And
is,
you're getting just the remainder.
just the remainder. Kind of number 6 is in Python. For the Python compiler, when the Python compiler sees 6, it sees an int. It sees a built-in data type, 6, but it also sees 6 as a kind of number 6 is in Python. For the Python compiler, when the Python compiler sees 6, it sees an int. It sees a built-in data type, 6, but it also sees 6 as a representation of the object that contains 6 at the same time. Can be a string, a decimal number, and then all the methods that you can use on that, okay? So that's what an object is. So let's see, an object is simply a collection of data variables and functions that act on those data. And so if we go back here, the object 6 comes or has the literal value 6 and comes with, packaged with functions that you can use to modify 6. And let me read this line here. The symbol 6 represents, so when you think of 6, think of it as an int, as an integer, or if you really are, you want to think about it in a more complicated or precise manner, actually not complicated, but precise, the symbol 6 represents an object of type int in Python that contains the literal integer 6 in it. Okay.
Okay.
Right. All of that will be good later on. And here we have the object here. Let me pull my little, this is my laser. So the object here is in the box 6. So this green box represents the object. And we can see that in this object, in this box that represents the object, the integer 6 is in there already, and plus a bunch of functions that we can't see and are not represented. Think of a little plus sign in there next to the 6 and things like that. So functions and the data is in the object here, represented by the letter 6, and it is pointed to, or it's referred to, or is reachable because we have X telling us where it's sitting in the memory, okay? And in fact, what is X is the reference variable. And if we go on to the next slide, here we have, we'll skip this because we've done this already, but actually, let me read this. The letter 6 donates any object with, I think it's worth repeating and me reading it aloud, okay?
Mhm.
So I'm going to do that. So what is the literal 6? It donates, it represents any object whose value is the integer 6.
Okay.
Okay, plus it has methods, can be a string, a decimal number, and then all the methods that you can use on that, okay? So that's what an object is. So let's see, an object is simply a collection of data variables and functions that act on those data. And so if we go back here, the object 6 comes or has the literal value 6 and comes with, packaged with functions that you can use to modify 6. And let me read this line here. The symbol 6 represents, so when you think of 6, think of it as an int, as an integer, or if you really are, you want to think about it in a more complicated or precise manner, actually not complicated, but precise, the symbol 6 represents an object of type int in Python that contains the literal integer 6 in it. Okay.
Okay.
Right. Can be a string, a decimal number, and then all the methods that you can use on that, okay? So that's what an object is. So let's see, an object is simply a collection of data variables and functions that act on those data. And so if we go back here, the object 6 comes or has the literal value 6 and comes with, packaged with functions that you can use to modify 6. And let me read this line here. The symbol 6 represents, so when you think of 6, think of it as an int, as an integer, or if you really are, you want to think about it in a more complicated or precise manner, actually not complicated, but precise, the symbol 6 represents an object of type int in Python that contains the literal integer 6 in it. Okay.
Okay.
Right. All of that will be good later on. And here we have the object here. Let me pull my little, this is my laser. So the object here is in the box 6. So this green box represents the object. And we can see that in this object, in this box that represents the object, the integer 6 is in there already, and plus a bunch of functions that we can't see and are not represented. Think of a little plus sign in there next to the 6 and things like that. So functions and the data data is in the object here, represented by the letter 6, and it is pointed to, or it's referred to, or is reachable because we have X telling us where it's sitting in the memory, okay? And in fact, what is X is the reference variable. And if we go on to the next slide, here we have, we'll skip this because we've done this already, but actually, let me read this. The letter 6 donates any object with, I think it's worth repeating and me reading it aloud, okay?
Mhm.
So I'm going to do that. So what is the letter 6? It donates, it represents any object whose value is the integer 6.
Okay.
Okay, plus it has methods. So the object here is in the box 6. So this green box represents the object. And we can see that in this object, in this box that represents the object, the integer 6 is in there already, and plus a bunch of functions that we can't see and are not represented. Think of a little plus sign in there next to the 6 and things like that. So functions and the data is in the object here, represented by the letter 6, and it is pointed to, or it's referred to, or is reachable because we have X telling us where it's sitting in the memory. Computer, it's just beautiful. I'm going to do S1. Let's use the slide name, and I am going to do A, B, C. Now I hit enter. Now S1 points to ABC. If I want to know what S1 contains, let's say we've done a bunch of stuff after that, right? And we forgot. I mean, like, you want to know, hey, does S1 have ABC or does it have the string DEF? Let me check. The interactive session can tell me what it is. And it tells me it's ABC, okay? Now I'm gonna create, I want to assign another reference variable, another string DEF. If I wrote that, I would run into trouble because DEF is a keyword that is used when we are defining functions. So that would not work. So we need to put these double quotes. And now because now, okay, so let me do this again quickly. If I hit enter right now, the compiler will come and say, hey, what kind of object is this? And it will evaluate this object as a keyword, and it will say, oops, that's syntax error, doesn't work. Now
Okay.
I'm going to use the up key to get this back. Now I'm going to put these quotes around it. Now when the compiler comes and looks at the right-hand side and says to itself, hey, what kind of object is this? It goes, well, let me check. Oh, it has double quotes on both sides. That means it's a string. It does not then see it as a keyword used in the Python language, but as a string, and therefore it can do the assignment.
Okay.
Okay. Now, string is an object. This is an object. This is an object represented by ABC. This is a string object represented by DEF, because now if I type S2, DEF comes out. If I type S1, these are S1 points to ABC, S2 points to DEF.
Okay.
And what if we wanted to concatenate them, join them? What's the operator for that? The cheat sheet is on your left.
It's the plus symbol with
Yep.
the double quotes.
So one of the functions that strings come with, because they're objects, that we can use to modify strings is the concatenation. And it uses the same symbol as the addition symbol for int. So I'm going to write S1 plus S2. And when I hit enter, the first thing the compiler will do is evaluate what S2 is. it looks at S2 and goes, oh, okay, let me see in my memory. Oh yeah, there is a reference variable, S2, that points to a string. Then it goes here. It says, oh yeah, S1 is, I have S1 and it points to a string. Therefore, the plus symbol here in the middle, because it has a string before and after it, it's not the addition operator, but the concatenation operator. So I can join these two guys up. So I do this and it returns the answer.
Okay.
Okay.